All right. Before I get started on the vaccines, I want to mention that there's a section in here on parasites and a section in here on fungi. And it would be good for you to read through it, but I really don't have time to make a lot of videos concerning that. It's fairly easy to understand. So, what I am going to recommend you do is breeze through that pretty fast. And then when you get to the vaccine section, you really need to sit down and read the vaccine in pretty much detail. If you're going into medicine, if you're going into pharmaceuticals, pharmacy, then the vaccine section is going to be of interest to you. And it's something that's constantly changing. They're coming out with new vaccines. Also, you need to be able to argue with some of these anti vaccine people that are out there. They read some little story or anecdote on YouTube, or they watch Oprah Winfrey or other talk show hosts where they're talking about vaccines. There's a lot of evidence on the CDC website. You can go there and get a lot of data, or just look in some of the peer reviewed journals. Vaccines work, they've saved a lot of lives. There's very little um, harsh side effects, and a lot less than people seem to think. Yes, they do use a form of mercury to create vaccines, but it's ethyl mercury, which is taken care of in the body. It's like saying sodium is so bad. If you put sodium metal in water, it bubbles and boils up. Then why do they put it in food? It's put in food as sodium chloride. So the compound is different than the element. So you're going to see a lot of people arguing about the anti vaccine group, and we've got to educate people. The more people we can have vaccinated, the better the herd immunity is for the whole population. And the less likely we are to have outbreaks of some of these horrendous diseases. There are also some passive immunities that can be done. And remember, from the beginning of the semester, passive immunity is basically where you're giving antibodies formed by one host to another host to help neutralize some of the effects. So you can have black widow spider bites, and they cause, it's a neurotoxin, so it causes convulsions, causes the diaphragm to convulse, and it can cause loss of breathing. Depending on the source of the bite, it can be bad. Used to be really bad during the era where we had outhouses, because black widow spiders would bite men primarily on their dangly parts that went down in the outhouse area, and it would enter the bloodstream really fast, and then it would cause breathing issues and then death. But anyway, the way they get these antitoxins is they inject the toxin into an animal like a horse, um, or a pig or whatever, and then they go back and they take the antibodies. So they take the serum from those organisms, they take the antibodies, and they can inject them into a host. Usually, they don't like to use an antitoxin or antivenom from a horse or other animal more than once. Why? Because you can have an allergic response to the horse serum that's in there. So they can do this with snake venoms, black widow spider bites, botulinum, and they can neutralize the infection and actually save people. So if you look at the number of people that have gotten exposed to a disease like rabies, like botulinum, but they've survived, the number of deaths has dropped dramatically in the last, say, 20 or 30 years because of this passive immunity. It's not really vaccination, but it leads into it. So let's quickly look at this. I'm not going to go over the chart. If you're working in a pediatric office, you have recommended childhood immunization schedules that are laminated and put on the back of just about every door that the nurses and doctors use to remind them of when things are. And you start learning which ones are which. I do admit, and this is one of the biggest arguments a lot of mothers have against vaccines, is they give a lot of vaccines really early. Okay, they give them from 2 months to 6 months. There's quite a few vaccines that are recommended. The they have statistical reasons for why they want to do these things. But there can be issues with giving that many vaccines that close together um, to a young child, especially if the young child is being breastfed. Breastfeeding brings in maternal antibodies, and the antibodies from the mama can neutralize the antigen in the vaccine and prevent the vaccine from being as useful. That's my problem with it. Is they need to be very careful not to give uh, a lot of vaccines to infants that are breastfeeding. They need to move the time scale. They might want to even offer some of these mothers that are concerned about getting so many vaccines so fast kind of a staggered injection rate. So let them do it, um, go 2 or 3 times, and rather than getting 3 or 4 shots all at one time. That's just my personal opinion. I'm not the person that did the statistics on this, so they may have reasons for why they want to give all of these vaccines together. I just don't know what they are off the top of my head. So um, that's basically something. If you're doing it, you will learn it. But I do think vaccines are worthwhile, and I have my vaccines. I get the influenza vaccine every year. I get updates on whooping cough on a regular basis, etc. I highly recommend it. Um, well, here's just an example of some disease. The numbers of people infected, and then the vaccine comes out, and you can see within a couple of years, the number of cases of the disease have dropped to a very, very low number. Trying to see what this disease is. Oh, there it is. Measles vaccine. And there was a secondary effect of measles. It seems that measles was kind of like a gateway infection. So a lot of people would get measles, and then they would be prone to other diseases for several years after that. So after the measles vaccine first came out, um, in the years, let's say 68 and on, the number of deaths from a lot of different infectious diseases dropped dramatically, because what was happening is they would get measles, and then the next year after they'd gotten over the measles, they would get another disease that would cause their death or severe infection. So the number of cases of these other diseases dropped dramatically because the vaccine worked. It prevented them from getting that gateway infection. Now, common vaccines, you have live attenuated vaccines. So that's the organism is weakened, it's still alive. The problem with the live attenuated vaccines is that it does require refrigeration. So if it's not handled correctly, like if it's left out in a warehouse outside of refrigeration, it can cause it not to be effective. Um, it may mutate back to a more virulent form. It's not likely. It's 1 in 100 million cases or something, but the potential is still there. It does offer you a much stronger response than a killed or total inactivated response, especially with the viruses, because viruses, as you know, have early genes that are turned on, genes that are turned on in the middle of their replication cycle, and then late genes that are turned on. So if you have a killed virus, it doesn't try to turn on any of those other genes that could be potential antigens to develop antibodies against. So a live attenuated virus is going to try to infect. So as it tries to infect, then it's going to turn on different genes, and it gives you a much stronger immune response over an inactivated. I just basically talked about inactivated or heat killed viruses. One that I want to mention is the Salk vaccine. See, polio up here, there's a live attenuated vaccine, and then there's a Salk vaccine, which is a killed. These two guys were competing to see who could come up with the vaccine first. Fascinating story, but uh, what they were proposing to do for a period of time was to give one or two vaccines with the Salk, which would raise some immunity to the polio vaccine, and then come back with a Sabin vaccine. Um, and that's still used in some countries today. Now, other types of vaccine, toxoid vaccines. So you're raising a vaccine against the toxin, neutralizing the toxin. Subunit vaccine. Um, you can take a subunit of a exotoxin um, and use that to raise specific antigens that lower adverse responses. It's very difficult to develop, so subunit vaccines are expensive and they're hard to use. So they're still trying to come out with some new ones, like they've got conjugate vaccines. Basically, they'll take and conjugate a piece of antigen from a protein onto another molecule that makes it work as an antigen, as a vaccine, and then they have zero chance of getting the infection. DNA based vaccines, um, these are in clinical trials. There's a slide coming up, and I'll talk about those in detail. These are great at both humoral and cellular immune responses. It says they're not available yet, but I heard last year that some were on the market. So the book's a little dated in that respect. Recombinant vector vaccines, you can mimic natural infections by putting some genes into different viruses, and you get a much stronger response. And they can also take, with these conjugate vaccines, they can put different antigens from different pathogens into one vaccine and give you a strong response to multiple different pathogens all at one time. The beauty of that is that they're reducing the number of antigens they're injecting into the patient, thereby they're reducing the total polyclonal antibody production. Um, they're much more efficient and much less chance of cross reactivity. Vaccinia vectored vaccine. So you can take, and the reason this works is because the Vaccinia virus looks like it's going to try to infect the cells. So what you do is you take a plasmid, you put a Vaccinia promoter that will allow the Vaccinia virus to actually use it, and then you put DNA from an antigen from a pathogen. Remember, this is not the whole pathogen. This is really just a piece of it. So when you put that together and you put it into a plasmid and then you put it into a Vaccinia virus and use that vector, the Vaccinia virus is going to try to infect cells and it's going to produce the plasmid. So when the plasmid is produced inside the cell, that will stimulate endogenously obtained antigen to be processed, and that's going to stimulate cytotoxic T cells, cytotoxic T cells to attack those cells. They can also release some of the protein to the outside world, and you'll get some humoral immune response. But this is really good at developing a cytotoxic T cell response or cell-mediated response. There are clinical trials for a lot of vaccines that are DNA based. There's HIV, there's influenza, there's some cancers that are being looked at. They just came out with a new malaria vaccine that's in trials in Africa right now. Bladder cancer, Ebola virus, human papilloma viruses, those are in use, but not DNA based. Look, they're coming out with possible vaccines against cancers. This is a good thing. This is how a toxoid vaccine works. So you take a polysaccharide coating from a bacterium, and then you link it to a toxoid, and it can be used in conjugate vaccines. So now I can take this and put it into a vaccine, but I can do the same thing for multiple different organisms, and I can develop one vaccine against multiple different pathogens all at one time. Now, you can take detergents, and you make what are called micelles. This is immuno, immunology or immunological stimulating complexes is basically what it's talking about. So you mix detergents, and the soluble proteins from an antigen can become trapped inside these detergents. So there's a phospholipid bilayer. This is basically a liposome. And then the antigens are trapped on the inside. So basically, what happens is the stimulating complexes deliver the antigen by binding to the cell surface of the membrane, and it pushes those peptides that have been trapped in the middle into the inside of the cell, so that you get a T helper, I'm sorry, a MHC class 1 molecule expressing antigen on the outside, and you get a cell mediated response. This is kind of a beautiful way of doing it, because now any infected cells with intracellular parasites can be targeted by cytotoxic or natural killer cells and destroyed.